Okay, similar to this morning section, some of you have already fulfilled your assignment to watch this video. Some you haven't, so I will give a quick review so that we can make a connection for today's lecture. This diagram, we bring budget line and indifferent curve together to analyze consumers' choice. First, we have two goods, pizza and Pepsi, X and Y. And recall that this person or this consumer, he wants to maximize his utility. From pizza and Pepsi consumption, subject to budget constraint. So the question is, which basket gives the maximum of utility? Okay, so take a look at this. We have the budget line, this black one. And then we introduce indifferent curve into this diagram. Yeah, okay. We have IC1, IC2, IC3, IC4. Or we can call U1, U2, U3, U4. All right. We have several baskets here that we want to take a look. Basket A, B, C, D, E, F, G. And which basket maximize utility? Which basket do you think maximize utility given the budget constraint? Basket C? Why not G? Why not G? Why? Say it. Why? He cannot afford. Okay. He cannot afford G. So G cannot. Your friend recommend basket C. Why not F? C is? C is on the higher indifferent curve. And secondly, point F, it's on the lower indifferent curve. And he didn't spend up his resources. So he has some money left to make himself happier. Okay. Then G is not G out of question. F, no. Why not B? Why not basket B? Or A, or D, or C, or E? Why C? Because you recommend C, I can also see that A, B, C, D, E are on the same budget line. All of them are on the same budget line. So I ask you, why not A or B or D or E? Notice that basket C is on IC3. Basket B is on IC2, D as well, lower utility level. Even worse, A and E are on the IC1, even lower utility level. Even though A, B, C, D, E, all basket here cost the same expense. They are on the same budget line. But to spend money wisely, spend it up wisely, he must select the basket that bring himself to the highest possible indifferent curve, which is basket C. All right? Okay. So we call basket C utility maximizing basket. Okay. Next. In the video, we take a closer look on basket C. We found out this. When we measure slope of two things here at point C, slope of indifferent curve at point C, you can find the tangency line pass through touch point C. This red pen, its slope reflects slope of indifferent curve, evaluate at point C. If you evaluate at different point, different slope, yeah, like this, like this, like this, no. At point C, yeah, tangency line here reflects slope of indifferent curve at point C. Next, slope of budget line at point C. This black line share the same slope as this. So at point C, basket C, slope of indifferent curve, the red pen, equal to slope of budget line, the blue pen. Notice also that this condition is not true here. Here, indifferent curve, it's a lot steeper than budget line. This condition is not true at point D or E as well. Slope of IC and budget line are not the same. Only at this point C that both share the same slope. So we wrote at basket C, slope of IC equal to slope of budget line. And then we argue next, what is the slope of indifferent curve then? Slope of IC is marginal rate of substitution between pizza and Pepsi. Slope of budget line is a price ratio or relative price. Okay, ignore the sign for a moment. MRS, slope of indifferent curve, PX over PY, slope of the budget line. What is MRS? Marginal rate of substitution. What is your nickname? What is your nickname?
Pair. Pair.
Pair. P-E-A-R?
Yes.
What is MRS pair?
Marginal rate of substitution.
Yes. What is all about this rate then?
It's
what?
a slope of IC.
It's slope of indifferent curve. Yes. And what else?
Yeah, it's an opportunity cost
Opportunity cost of what?
of good X and Y. Good X.
Opportunity cost of good X. Right. Opportunity cost of good X. Yeah. Can you say something more about that? Opportunity cost of good X. Okay, opportunity cost of good X. Can look at MRS. Okay. MRS is opportunity cost of good X. Yeah. Okay. You too. What is MRS? This side said MRS is the opportunity cost of good X. How about you guys? What is MRS? You first. MRS. What is MRS? This is not a picture for MRS. Give it a try. What is MRS? Say something. What is MIS?
Opportunity, opportunity, cost of good. Why?
Oh, you got a competitor. They said MIS is opportunity cost of good wine of Pepsi. For you, opportunity cost of pizza. Oh, third version. Opportunity cost between both. Now, I'm wondering about your final exam, MRS. One more time. What is MRS? What is MRS? I forgot your nickname. Ah, okay. Special nickname. What is MRS?
Amount of one good a consumer is willing to give up to have one more unit of another good.
Say it again. Amount
Amount of one good that
of one good that.
is willing to give. Amount of one good a consumer is willing to give up to have one more unit of another good.
Okay. Then if I say that MRS is equal to -8, what does -8 mean then? When you said amount of one good, this guy willing to give up for another good. If he said, my MRS is 8, what does he mean? Can you interpret -8 inwards? What this guy tried to say? This is about pizza and Pepsi.
One willing to satisfy.
Oh, you want to say something? Yeah, you can give it a try then. Yeah. Teamwork.
Amount that he willing to sacrifice.
Then he said -8. What does this rate mean? -8. He willing to give up.
He willing to give up 8 pizza to 1 can of Pepsi.
Not another way around. Is delta y over delta x? Yeah. He is willing to give up 8 of good y for 1 of good x. So he willing to give up 8 Pepsi for 1 pizza when he is hungry. Thank you. You no. MRS is not opportunity cost. Opportunity cost is the other thing here. Slope of budget line is opportunity cost of good x. Incorrect, and incorrect. Okay. Wow. Okay. At basket C, MRS equal to price ratio. And we call this condition utility maximizing rule. That means to maximize utility given the budget constraint, recommendation is he must spend money in such a way that once money is spent up, this condition is fulfilled. And we already see that this is the only one place that this condition is fulfilled is to buy basket C. Slope of IC equal to slope of budget line. And the illustration here also suggests that A is not a good choice. And when we check with the rule that we have, this basket A does not fulfill the rule. Let's take a look what happens at basket A. Basket A, slope of indifferent curve is steeper than slope of budget line. So we can say that at basket A, MRS on the left it's higher than price ratio on the right. It must be this condition. Yeah. Then MRS is a willingness to give up Pepsi for pizza. Let's say, since slope here is quite high, let's assume that MRS here is equal to -8. The magnitude is 8. So this guy said, oh, look at the amount of pizza and Pepsi in basket A. At basket A, he must be hungry. He has a little amount of pizza, but a lot of Pepsi. He willing to give up a lot of things that he has plenty of in exchange for another good that he has a few. So when he is hungry, he said he willing to give up 8 units of good wine, Pepsi, to get 1 slice of pizza. So this is -8 means. When someone say this, we can interpret MRS as marginal benefit of pizza, MBX. Why we say this? Because this number reflect how hungry this guy is, yeah. How this guy value this slice of pizza. Let's say, if at basket A, he only has 1 pizza and a lot of Pepsi. When this guy said 8, that means to get the second slide, second unit, he willing to trade with 8 Pepsi. So he valued this piece number 2 very much. That's what he think about marginal benefit of pizza, the next slide that he is about to get. Then MRS reflect marginal benefit of good X. The higher the number, the higher valuation that he placed on pizza. And when he will place the high valuation on pizza when he is hungry. But if you ask him the same question here, hey, mister, somewhere here, let's say, how many Pepsi you want to trade for pizza? MRS is very low because he almost full. Then he will say something like, oh, maybe one can of Pepsi, for example. Yeah. So, take home message, MRS reflect marginal benefit. Now, marginal benefit of pizza is quite high at this moment, around point A. He walked to the market, meet with a seller. This guy in his shop, let's say it's your shop, you can also offer him pizza and Pepsi. You sell these 2 goods. And look at the term of trade here. Let's say pizza is 100 baht per piece. Pepsi is 50 baht per can. When we do this ratio, PX over PY, we got 2. Now it's your turn. I mean, your answer is this one. This -2 is an opportunity cost of pizza. The seller said to him, you can have a slice of pizza when you give the seller 2 cans of Pepsi. It's a marginal cost of pizza. This guy must exchange with 2 cans of Pepsi. And he must be very delighted because in his mind, he prepared to give up 8. But the seller asked only 2. So when marginal benefit is higher than marginal cost, what this guy would do? Wow, he keep exchange for pizza. As long as marginal benefit outweighs marginal cost, extra benefit higher than extra cost, he keep eating more of good X. Then in the picture, he walked downwards. Buy more pizza, buy less Pepsi. It's about walking along the budget line. Downwards, 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 downwards. And now, let's say he keep walking until arrive at point B. We stop him again. Hey, what is your MIS now? And he said 5. Are you surprised why it's less than 8? No. He must be already okay with his hunger. Then compare B and A. Of course, at point B, MIS must be lower. Now he willing to give up only 5 cans of Pepsi for one slice of pizza, he become less hungry. But still, compare with marginal cost. As marginal benefit that he feel about this slide, still higher than marginal cost, which is 2. He keep eating more pizza. Yeah. So he continue to consume more of good eggs as long as MB higher than MC. Now it's time to stop. Once he arrived at point C, we can see already that MRS equal to PX over PY already -2 equal to -2, by the way. Then he stopped trading now. Equilibrium is here. He make no further trade. Once he arrived at this basket C, so it's a utility maximizing basket. You can see that if this guy is so stupid, if he trade more, he will fall to the lower indifferent curve. Walk away from point C, fall to the lower IC already. No, he will not do this. Then he stopped here. Stable equilibrium is here. No incentive to trade more or trade less. Yeah, okay. All right. So, okay. This is our explanation in the record video that I asked you to watch. Yeah. Now, okay. This is a new stuff for today. Second version of the rule. Today, we first take a look at this second version of utility maximizing rule. The original version is MRS equal to price ratio. We just observed. Now, second version is this. What is MU? MU. MU stand for marginal utility. Okay. What is marginal utility then? Definition of marginal utility. Marginal means extra. Marginal means additional. What does additional utility means? MU, marginal utility. Together, find out. I will come back. MU, what is MU? Yeah. All right. Ready? Okay, and back. What is MU? Yes, somewhere around there. What is MU? Increase in utility? Increase in utility? Can you read this? Marginal utility is?
It's an increase in utility following the consumption of an extra unit of food.
If you drink the next can of Pepsi, additional utility that you received, we call marginal utility. Yeah, it's an extra utility from extra unit of the good, MU. Here, we will prove that this MRS, the original recipe is it's equal to delta Y over delta X. That's our original recipe. But now we will prove that it can be written as ratio of marginal utility between pizza and Pepsi. Let's start. We start with an indifferent curve IC1 with a basket on it, basket A, with X1 and Y1. Now, this consumer stay at A. We are going to move him to somewhere that hurt him a lot. We move him to basket B. We essentially reduce amount of pizza from his basket. We make delta X here. Remove some pizza from him. He come to this spot. Remaining basket now, basket B. And if you imagine, there must be an indifferent curve that passed through point B and it stay lower than the black IC. Let's call this IC 0. So illustration suggests that when we take away some pizza from this guy, he upset about it. He fall to the lower indifferent curve. So movement from A to B create utility loss. To this guy. And utility loss equal to marginal utility from pizza times amount of pizza that we steal from him. Delta X is here. Amount of pizza that we take away from him is delta X. For example, if we take away 10 slices from him, minus 10 here, suppose MU per unit is like maybe 10, let's say, then he lost about 100 joules. That's a numerical example to make you understand what is this to the product of this. Yeah, it's represent utility loss 100 utils. Now he is upset. He is being upset about this. We said, never mind, mister. We are going to bring you back to the old happiness level. So we are going to give him Pepsi. Look, and we start to give him some Pepsi, but he still said, no, it's not enough, it's not enough. Now, once arrived at point C, he said, okay, he is satisfied with this compensation already. We bring him back to the same utility curve. So point C and point A generate the same happiness level already. So once we give him extra cans of Pepsi, delta Y here, we bring him back to the same indifferent curve, arrive at point C. So movement from B to C creates utility gain. And the utility gain that he received equal to marginal utility from Pepsi times amount of Pepsi that we give him, amount of Pepsi that we compensate to him, this delta Y. For example, let's say if MUY equal to 20, how many Pepsi we should give to him so that it's counterbalanced with utility loss? 5. Okay. Plus 5 cans. Then cancel out completely, fully offset with the loss that we generate to him before. Yeah. Then what we learn here? A to B create loss of 100. But then we bring him from B to C, create gains of 100. Then we found out that it makes no difference when we travel from A to C. A to C, no change in utility if we travel along the same indifferent curve. Change in utility is 0. Yeah, it's true. 0. Then argument next is A to B is a utility loss plus B to C is about utility gain. And it doesn't change anything. Change in utility is 0. So we rearrange this equation. Finally, we obtained what we try to prove that, oh, this MRS can be written as this MU ratio. Yeah. Okay, once we got this, we utilize it. It's not, we didn't do this for fun. We will use it next. Okay. At the consumer equilibrium basket C, we know that slope of IC and slope of budget line are the same. And we come back to check what we have now. Once we got the new version of MRS, we replace it here. We replace it here and we derive a minus cancel out. We got ratio of MU equal to ratio of price. And then we rearrange. We got MUX divided by price of good X equal to MUY divided by price of good Y. And this is not the new thing that you see. We observe this in cardinal approach already with Jeremy Bentham, the guy that assumed that utility is measurable. We found this rule already. So key point here is, okay, I let you finish this first. You should go to watch your face and come back. Okay. Ah, okay, seems that most of you are ready. Now, summary. There are two approaches that we study in theory of consumer choice. First approach we called audit a cardinal approach, which assume that happiness can be measured and the unit of measurement is called utils. That's by Jeremy Bentham. And after his work, which assume that utility is measurable, we play this utility maximizing game. If you notice, at the end of the game, we found this conclusion on the utility maximizing rule. And surprisingly, even though the two gentlemen here attack on Jeremy Bentham about his assumptions on the measurable utility, these two guys, Slutsky and Hicks, ordinal approach said we don't need to assume that people can state their happiness in terms of quantitative terms like utils. We only require a person when we want to study his behavior. This guy must be able to rank the basket. That's enough. But at the end, we use IC, we use budget line. Oh, that's look arrogant tools. At the end, we come up with the same thing that Jeremy Bentham discovered. So similar to you can take bus or take BTS to Thammasat, Thapachan. Yeah. Different approach, but deliver the same outcome on advice on utility maximization. Yeah. If a person want to spend budget, limited budget to maximize utility, he must spend such that last baht spent on X and last baht spent on Y generate the same MU. That's the recommendation. Yeah. Put it differently, to maximize utility, the advice is once money is spent up, marginal utility from X per baht from X and marginal utility per baht from Y must be equal. If you have one last precious minute in the final exam, and you have two questions that you can choose to spend one last minute, of course, you would think first whether you want to spend one last resource here to question one or question two, which question generate marginal score per minute higher than the other questions, then you would spend your last baht, last minute towards the one that generate higher MU per minute. That's it. Yeah. Okay, that's a recommendation by these three people here. All right. Now we come to the new section here. Okay. we start with the basic recognition that with this pizza Pepsi story, if price of good X pizza change or price of Pepsi good Y change, or his parents changed the income that given to this guy, change in M. All changes here affect a choice chosen by this guy. When something happened to PX, PY, and M, this guy may change his basket of consumption. Okay, so effect of price or income change on a consumer choice. Okay, take a look at this. Start with this. Consider a situation where price of good X goes up. Pizza become more expensive actually. Example, only variable that changed here is price of good X pizza. Let's call last week it used to be 100, and this week it jumped to 200 baht per piece. So we consider the situation where pizza become more expensive. And with a simple calculation, we learn something from this. The price ratio change. It used to be 100 divided by 50, that PX over PY, relative price, ราคาเปรียบเทียบ yeah, or price ratio. It used to be this, 2 with minus reflect the trade-off. And the new price ratio become minus 4. 200 divided by 50. So it means that last week, opportunity cost of pizza is only 2 cans of Pepsi for gone. When he want to accumulate 100 baht to buy a pizza, he must reduce his consumption on Pepsi by 2 units, so that he will have 100 baht ready for buy a pizza. But this week, he must give up his consumption of Pepsi by 4 cans to gather 200 baht to buy pizza. We said Formally speaking, opportunity cost of pizza become more expensive. Yeah. Whatever you want to say, reflect in this -2 become -4. Interpretation to this guy is, hey, now you are facing with this situation. Opportunity cost means what you have to give up when you want to eat a pizza. Opportunity cost goes up. Marginal cost of pizza goes up. Friendly speaking is pizza become more expensive relative to Pepsi. Natural language. This is a mathematical language. Slope of budget line change. Then when we transform this finding to the picture, we must see that budget line, the new budget line must be steeper because this magnitude increase. Let's check then. Okay. All right. Illustration come. Draw a picture that describe what this guy is facing now. We introduce original budget line. Let's name it BL1. Yeah. And then we introduce preference curve, namely IC. Let's call IC1. Okay. Let me look at your IC. How you draw this IC. Where's your IC? Can you draw similar to mine? How about your IC? Recommendation: do not allow for any part that contains positive slope. Yeah. If you have positive slope part, try to delete it. Yeah. Okay. Okay. Let's call basket A then. Contains X1 slice of pizza, and Y1 units of Pepsi. Nothing happens yet. Yeah. Before the change, we just report what the picture said before the change. Given price of pizza, Pepsi, and M, basket A, X1, Y1, maximize his utility level. He is on indifferent curve 1. Okay. Next, he got an attack. Price of pizza goes up. Then budget line will rotate. How budget line will rotate, or how budget line will change when price of pizza become more expensive. In other words, can you draw the new budget line BL2? I have BL1 already, the black one. Can you suggest about BL2? Draw it, I will see. Yeah, draw it. Oh, it swing inward, right? Confidence? Yes. Right. Budget line swing inward. Yeah. Become steeper. Okay. Name it BL2. So the result, budget line rotate. หมุนเนี่ย rotate or swing, or you can use the word pivot, inward. From where to where? From BL1 to BL2. From black to red budget line. Notice that slope becomes steeper. Slope of budget line becomes steeper. So which one you cannot read? Pivot, swing, or rotate. Maybe you want to come to sit here. I just wonder which word that you try to see. All words. Oh, I should improve my handwriting then. Sorry. Ah. Number two, just report what we see in the picture. Budget line swing inward, become steeper. Link with the numerical example above. Yeah, exactly. Slope increase from 2 to 4 like this, become steeper. Opportunity cost of pizza increase. Yeah, the picture said. Now, this guy, he cannot buy basket A anymore. Now, basket A, it's beyond his budget set. The best he could do now, if he want to spend up all income 2,000 baht, he must spend along this red basket, let me call. Basket on the red budget line. That's what he can spend his income on at the frontier. A cannot. Then his new choice, we're talking about effect of price change on consumer choice. His new choice must be along this new budget line. Okay, check possibility. If it's here, let's call it's here. The purple basket. If he select purple basket, of course with a different curve, it would mean that he decide, coping with this incident, he decide to buy less of pizza and less of Pepsi. Possible. Or he select orange basket. That would imply this guy decide to buy less of pizza but still buy the same amount of Pepsi. Possible. And if he select the green, it would mean that he decide to buy less of pizza and more of Pepsi. Yeah. But whatever he decide, he buy less of pizza. Whether purple or orange or green, he buy less of pizza for sure. But for Pepsi, it depends. He could buy less of Pepsi too. He could buy the same amount. He could increase his consumption of Pepsi. It depends on his preference. Okay. Now, select one case to take a look more. I cannot present the 3 cases here. I select one. Okay. Let's assume this, that he end up with basket C, green basket, where he buy less of good X. Let's call this place X3. He buy more of good Y. Let's call this place Y3. Okay. What? This is his response. Let's say, buy less of X, buy more of Y. New choice is choice C. Summarize this. And I give you a remark. There are many possibilities, but now at the moment, just stick with this possibility and try to discover more what happened. Yeah. He select basket C, the green basket, to be his new choice. Let's say. And when we compare what he did, what he did compared to the original choice, we observe that he buy less of pizza. X3 is on the left of X1, and Y3 is above Y1. That means he buy more of Pepsi. Okay. And result, he upset about this new choice. Of course, his utility fault. He is now on the lower indifferent curve, namely IC0, IC0. Okay. That's the outcome of pizza price become more expensive. Yeah. Now, number 4. Then question 4. Point number 4 question. We ask economic question. Is there any explanation why this guy buy less of pizza when pizza become more expensive? What are the driving force? What are the factors that motivate him to behave in this way? Yeah. And highlight for today is these two things. Two factors that drive him to buy less of good eggs when eggs become more expensive. Factor number one, he behaved in this way. It's because of substitution effect. Factor number two, he buy less of pizza because of another reason, another driving force. It's called income effect. In Thai ผลทางการทดแทนผลทางรายได้ Okay. Let's sum pink and blue together. If we sum the two combined effects together, we call total effect, TE. You should keep track on this, yeah. Give different color to these three things, yeah. Up to you. We will continue like this throughout. Yeah. SE for my version is a pink color, or I call pink effect. Income effect is a blue color for me. And when I sum it, I call total effects. I use orange color. Total effect. Okay, basically, substitution effect is about he might buy less of pizza because pizza become more expensive relative to Pepsi. That's one reason. So we wrote he changed amount of consumption of pizza due to the fact that pizza become more expensive. Relative price change, as you observe, PX over PY change suggests that pizza become more expensive. Then he buy less of pizza. Another reason that pushed him to buy less of pizza too is when X become more expensive, it reduce his purchasing power. He feel poorer. he feel poorer. How? Like this. Example, use the previous example, yeah. Now I'm going to explain what does it mean by change in real income or change in purchasing power. Yeah. อำนาจการซื้อ yeah. Real income รายได้ที่เป็นตัวรายได้ที่แท้จริง real income. Okay. Before M2000 original price of pizza 100. Given this, he can compute spend all money towards pizza will give him the maximum of 20 units. Okay. But once pizza price goes up, PX dash 200, he checked his affordability on pizza. He quickly compute M divided by the new price of pizza. 2000 divided by 200 now. It become only 10, the max. So he feels sad about this. He feel effectively poorer. Effectively poorer. We use this term because no one steal his money. 2000 still in his pocket. But the power of this money to afford pizza reduce. Cut half, yeah. 20 last week, this week only 10. Oh, we call this real income reduce, purchasing power reduce. Yeah. Okay. Similar to inflation, inflation also destroy power of the money in your pocket to buy things. Yeah. Yeah. เงินเฟ้อ yeah. That means if you want to have the same amount of the goods that you want, you have to put more money on it. Yeah. Yeah. Last year, let's say 50 baht can afford a bowl of noodle. But if this year you need to have 60 baht, yeah, your purchasing power fall. Yeah. Okay. So now SE, the pink one, is about he changed his consumption on pizza because pizza looked more expensive. Second reason, he changed his consumption on pizza because he feel that he is poorer, affected by increase in price of pizza. Real income fall. Two combined reasons create the total impact. Yeah. Total impact that we observe in the graph is this. This is total impact, the orange one. You should write TE here. This is a total impact, which we know that, it's a mixture of pink and blue effect that drive him to buy from X1 to X3. Total impact, total effect. Total effect on good wine also here from original to the new choice. A Amsterdam to C Copenhagen. Yeah, here. All right. All right. Here is a basic understanding. Now, We talk more about this substitution effect. Change in quantity demand for pizza good X. Why change? Because relative price change. What is relative price? The ratio of pizza, price of pizza and price of Pepsi change. You see from the budget line. Pizza become more expensive. Formal definition, we must add this red statement here. He make this adjustment with a goal. He make this adjustment by buy less of pizza, buy more of Pepsi due to change in relative price, because he want to hold his utility at the same level. He want to hold, we will see this in the picture, yeah, don't worry. This part suggests why he has to do this. The reason to hold or to maintain his current happiness, to survive. Let's see. We always work on convex IC, yeah? Okay. This picture will explain what is substitution effect. And once you see this picture, you should have a better understanding on this, why we have to add this red part in order to hold or maintain utility here. Let's start. Create a budget line. This green budget line, let's call BL1. Given this budget line, tangent IC at basket A, given this indifferent curve, and given this budget line, the green one, A is the optimal choice for him. X1, Y1 unit. Rational spending rule or utility maximizing rule is true here. Slope of IC equal to slope of budget line. We check, double check. A is a utility maximizing choice at this moment. And add more info here. Slope of budget line is a price ratio. Let's call this the green ratio, Px over Py. Green slope, green ratio. Yeah. Next. Okay. We are going to start to check what he will do if we change the budget line. We will twist the budget line, twist, and see what he will do. Now it's a green. I'm going to twist to become steeper. Let's use another color. Ah, we twist it to become the blue one. Let's call this blue one BL2. And the new choice that he select, he want to optimize, he select basket B. X2 and Y2. Now, the blue one with the blue slope, with the blue price ratio, given this, he select choice basket B to consume and maximize utility. Last attempt, we check again. What did we make it? Even steeper? Link with the red budget line. He selects C. Rate ratio correspond with choice C. The red one, let's name BL3, budget line 3. And we also observe this, yeah. The red one is the steepest one. Slope of BL3, it's higher, it's steeper than slope of BL2. BL2 is steeper than BL1. Okay. Or we can say that the rate ratio, the red relative price is higher than the blue relative price, and the blue is higher than the green relative price. There are 3 price ratios here. And now we can arrange from highest to the lowest. Now, let's talk about intuition behind this. Read from right to left. Our simulation is like this. Start with green. Green become blue. Blue become red. move from right to left. That means this ratio keep increasing. What is this ratio? Opportunity cost of pizza become more and more and more and more expensive. Yeah. Okay, write this. Yeah. The arrow go this way means that pizza become more and more expensive. Relative to Pepsi เปรียบเทียบกับ Pepsi price remain the same. So when PX goes up, PY stay the same. Yeah. Pizza become more expensive relative to Pepsi. Then what he did, we introduced this situation to him. Let's make pizza become more expensive relative to Pepsi and want to see how his choice changed. Okay, first time, A to B. Let's see what's going on here. When pizza become more expensive relative to Pepsi, when you check budget line, the blue one, stop writing now. The blue budget line now, A outside the blue. He cannot afford A. But if his goal is that I want to be on IC1, this is a goal. I want to maintain my happiness level. I want to make it no change. What he will do? You are smart. If you buy less of X and more of Y, you can maintain yourself on IC1. He do a smart substitution. Buy less of the things that become more expensive. Buy more of the things that become less expensive relatively. Can fulfill his goal, holding his utility constant, maintain his utility. A to B. Check the two baskets are indifferent. Same utility. His utility resume after he coped with these incidents. Relative price change. One more time. Relative price change again. Pizza become more expensive again. Red, blue tweets become red. Oh, now B cannot afford. Now B is outside the red budget line already. But what he can do, again, buy less of pizza, buy more of Pepsi. Doing this substitution help him to maintain his utility on IC1. That's the definition of substitution effects. That substitution effect in action, what he will do to maintain his utility. All right, explained by this diagram. When budget lines twist like this, it's about relative price change, like we discussed here. Okay. So I summarize for you. When pizza become more expensive, notice that he did substitution. he make this smart move. He did substitution, buy less of the good that become more expensive, that buy less of pizza, and buy more of the good that become relatively cheaper, that's Pepsi. By doing so, he successfully maintained his current utility level on IC1. Okay. He did substitution on purpose, with purpose. Yeah. Okay. Now, income effect. Yeah. Before, when price of pizza become more expensive, this guy buy less of pizza due to change in relative price. We call this substitution effect. Another part of the reason why he buy less of pizza is income effect. Income effect is about change in quantity demand for pizza when he's purchased. Okay. So income effect, he changed his quantity purchase on Good X pizza because he feel poorer. Increase in price of Good X reduce his real income. Okay. In other words, income effects, it's about effect of being poorer or being richer. Okay. Good X. If Good X is the normal good, when he become richer, he buy more. If he become poorer, he buy less. That's the definition of normal good. Inferior good, like a artificial product, like a second-hand product. When real income increase, when consumer real income increase, buy less. But when consumer feel poorer, consumer buy more of inferior good. Okay. Okay. Now, case one. When good X and good Y are normal good, that means if he become poorer, he will buy less of the two goods. Increase in price of good X. Change this ratio. This price ratio become more expensive. It gets higher. Opportunity cost of pizza increase. When pizza become more expensive, via substitution effect. So he buy less of X and more of Y. Via substitution effect. Second branch of the total effect. It's about income effect. Increase in price of pizza make his purchasing power fall. Real income fall. Since the two goods are normal goods, when real income fall, this guy react by buy less of pizza and less of Pepsi. That's income effect. He feel poorer, and then he buy less of the two. He buy less of X and less of Y. And if you notice, SE drive him to buy less of good X, i.e. also drive him to buy less of good X too, then no doubt he buy less of good X due to income and substitution effects. Look, PX goes up, it's a starting point. Outcome, buy less of good X. Here is a mechanism in his mind explained by SE and IE. How about good Y? Good Y. What is the net outcome then? Good Y. What would be the conclusion on good Y?
It's gonna be like one more, one less.
SE drive him to buy more of good Y, more Pepsi. IE drive him to buy less of Pepsi. What is the net impact on good Y then? Because now SE and IE move in the opposite direction. What would you say then?
So if
Yes.
if more of good Y, right, increase and the another options like less of Y, then it depends like which one is more
It depends on which one is stronger.
stronger.
Okay. Then what you should say is, if SE that drive him to buy more of Y is stronger than IE that drive him to buy less of good Y, then at the end he will buy more of good Y. Okay. So here effects on good Y depends. If SE on Y is stronger than IE on Y, result he will buy more of good Y. But if income effects on good Y that drive him to buy less of Y is stronger than SE that drive him to buy more, then at the end he will buy less of good Y. Okay. All right. Now we will translate this diagram to be a picture. Okay, now this part is quite technical. You have to pay more attention on this. Okay, we start with basket A. Given P, X, P, Y, and M, he maximized utility by choosing basket A with X1 and Y1. Now, price of pizza goes up. Budget line then rotate inward. Okay. To become BL2. Now, the new choice, it's choice C. Okay. We report old and new choice here. X1 to X3, its total impact on good X. When price of pizza become more expensive, I'm going to use the orange arrow report TE. Also, good Y. Total impact on good Y here. From Y1 to Y3. Okay. And we observe that he buy less of good X and more of good Y with this response. X1 to X3. X3 is on the left of X1, so he buy less of good X. Y3 is above Y1. He buy more of good Y. And what he is now, he's on lower indifferent curve. I see 0. His utility fall. Yeah. Okay. Next. We know that this adjustment from x1 to x3, which we call total impact, total effect. When pizza become more expensive, we know that it's a mixture of subtraction effect and income effect. Same is true for this good one. Now, we want to break down total effect into two separate effects, namely SE and IE. Originally, this ball is a mixture of SE and IE, and you want to use hammer to break it to see what is the size of SE and IE. Now we don't know the size. Okay. Additional explanation is this. Actually, we don't know what is inside this total effect, or we don't know the combination, the exact combination of the two. It could be full of the pink effect only. That means no income effect. Or another extreme, it could be only the blue ball, no SE at all, or something in between. We don't know. We will know only we try to find a tool that can separate them logically, separate them. So then we can see the clear size of SE and IE. And now we are going to do it. So breaking down the IE and SE will allow us to see SE and IE separately. Three of you, please be quiet. Okay. Let's do it now. Technical method to decompose, to break down the ball of TE into substituent effect and income effects. Create a line, so-called budget line. Sorry, hypothetical budget line. Such that this line must parallel with the new budget line BL2. Okay, we have two requirements for this line. Yeah. This line must parallel with the new budget line. First. Second, this line must touch at his O indifferent curve, namely IC1. Okay. Okay. Parallel and touch. Keywords. Go back to the picture again. This is a new budget line BL2. We're going to construct a line that parallel to this rate. And then I just copy this rate now. And change the color. Okay, we are ready. Create the line here parallel with the red and bring it to touch with the O indifferent curve. Basically, you just slide it back until it's touched somewhere. Okay. Job done. BL2 dash. The reason why we write BL2 to indicate that this blue share the same slope as the red is a new price ratio that this guy confront with. With that, just make the different hypothetical budget line. Okay. Check the property of this line again. Parallel with IC, parallel with BL2. Yes. Touch at the O indifferent curve. Yes. Touching point. Let's call point B. Touch, yeah, not cross. From B. Check the basket here. X2 and Y2. Okay. Success. And the instruction manual said the movement from basket A to basket B is about substitution effect. The movement from B to C is about income effect. We will see. Movement from A to B is about substitution effect. Movement from B to C is about income effect. Let's go to the picture. A to B first. In a substitution effect, it's a pink effect. Use this here. S dot E dot on good X. SE drive him to buy less of good X. Yes. SE drive him to buy more of good Y. Check A to B on good Y. Y1 to Y2. S dot E dot. The pink effect. Consistent with our flow diagram above, yeah, here. Substitution effect bring him to buy less of pizza and more of Pepsi. Now, consistent with the diagram above. Now, B to C, it's income effect. I use another color. B to C, it's about X2 to Y3, X2 to X3 on good X here. I dot E dot. When he become poorer, he buy less of pizza too. So SE and IE on good X pizza move into the same direction, drive him to buy less of pizza. Some SE and IE, we got this total effect, this orange color here. No doubt. Yeah. Check with the diagram. Yes. SE buy less of X. IE buy less of X. Yeah, less of X. Now good Y. Movement from B to C on good Y is here, from Y2 to Y3. Counter attack. Income effects. When good Y, when his purchasing power reduced and good Y is a normal good, he buy less of good Y due to the fact that he become poorer. So income effect reduce his purchase on, induce him to reduce the purchase on good Y. The picture review the net impact. SE is stronger than IE on good Y. Then that's why total effects, he buy more of good Y here. Okay. So with this technique, we can separate income effects and substitution effects together. Yeah. On good X and on good Y. On good X, we see this arrangement of the point CBA. A to B SE, B to C IE. There is no conflict between these two effects. Reinforce him to buy less of good X when price of good X goes up. One reason because relative price change, another reason because he feel poorer. Sum them up together become total effect. Yeah. Okay, that's a summary on good X. And you see X1, X2, and X3. Like this, yeah, X1, X2, X3. On good Y. An observation worth noting: when pizza is a normal good, we observe that pink and blue arrow move into the same direction, inducing him to buy less of pizza. Pizza becomes expensive. So we put this note here. SE and E move into the same direction when X is normal good. Later on, when we look at case 2, when X is inferior good, this will not be true. SE and IE will move in the opposite direction. Okay. Okay. That's a technical method to separate income and substitution effect. But we have no time yet to talk about intuition behind this method. Yeah. Yeah. Yes. You have a question? Wait. Any? Okay. In Crook Mankiw textbook, he will do the opposite way. Before we don't have this blue line, right? Mankiw said to separate income and subtraction effects in chapter 21. Yeah. Twist the budget line, twist the black budget line, twist the black budget line, step 1, until it share the same slope as red. Oh, yeah. Twist, stop. Until it share the same slope, you will find the touching point, point B. When you did this, then that's subtraction effect when you can spot point B. Movement from A to B, SE. Movement from A to B on good Y. Yeah, that's subtraction effect. Once you finish this, step 2, remaining impact. That's from B to C, refers to income effects. Effects of being poorer. Drive him to buy less of X, drive him to buy less of Y in this diagram. That's valid. Yeah. Again, Mankiw, step 1, twist the black budget line until it shares the same slope as the red. And then you can spot basket B. You got subtraction effects, and remaining refer to income effects. But what we did in the class, we did the opposite like this. We think about slide this blue until it's arrived at point until it's touched at IC1. The touching point is at point B. Okay, that's our approach. Why we have to do this? Because intuition at the last minute. Okay, maybe I say this. This guy, he got to complain when pizza become more expensive. He come to complain to you. First complaint is about, he said, he complained about change in relative price that forced him to do something. Second, he complained about, oh, my real income fall. Second complaint, my real income fall. In other words, he said, my purchasing power fall. In a dramatic sense, he said he got injured by subtraction effect and income effect. Please help. Okay, we understood. Now, the ball, the TE ball is a mixture of SE and IE. We know that. Yeah. But now we want to separate these two. Technique is this. If you use, let's say, a device to extract IE away, you can see the pure SE. Yeah. In other words, if you could remove income effect away first, you can see the clear subtraction effect. How to remove them. This guy said he got injured by change in relative price. One thing, he got injured by change in real income fall. Now, if we want to remove these two, separate these two, let's remove IE. Let's make this guy shut up about complain about income effect. He said his real income fall. Okay, we agree with him. Hey, if we compensate you with more money until your real income unchanged, you must shut up about this complaint, the second one. Okay, we said to him, shut up, second complaint. If I compensate you until the point that your real income is unchanged, stop complaining about this. Then he must only have leftover complaint is complain about change in relative price. In the picture, we do this. And I'm going to explain why this blue line helped. First, this guy is at point A. He is quite happy on IC1 already before the thing changed. Now bad news come. Pizza become more expensive. Budget line rotate inwards to BL2. He end up with the basket C, lower utility level. And he looked at the point A, his original happiness level is in the past already. With point C, it's full of income and subtraction effects we know. And now we want to separate the two. We got the technique already. We will make him shut up about the second complaint, income effect. Hey, I'm going to give you money. And we asked him, when you are going to stop complaining about this, he said, when I get back to my old happiness level, when he faced with the new price, if he get back to the original indifferent curve, he will stop complaining about income effect, the change in real income, the change in purchasing power. Okay, we start to do it with this red. Yeah, this is a budget line frontier now. We are going to virtually expand for him. Okay, mister, I will give you more money. Think about this as a boat. He jumped on this boat and start to travel. Stop. Shut up about complaint. Now you are already back to your indifferent curve IC1. Your real income has been resumed already. Your happiness regained. Stop complaining about change in purchasing power. We give you money already. Now he arrived at point B. Then point B, no IE anymore. And we observe this. He changed his basket from A to B. That means with subtraction effect, he buy less of X, more of Y to maintain his happiness on IC1. Yeah, that's subtraction effects. Then the remaining must be income effects. That's the intuition behind this blue line. Okay. That's it.